All right, today we're going to do the range of arc Z1 minus Z. It's not arc Z minus Z1, it's arc Z1 minus Z. So this is particularly hard given that Z lies on the circle. But I thought I'd do some circuit geometry revision first before I start that. So let's say you have a circle here, and you have a point here, and then you want to find the angle you want to find this angle here. And let's call this point -2 and 1. Let's call the center of a circle 3, 4. Yeah, so that's 4, and that's 3. So then the theory about circle is that from the center to the tangent through the point of contact, the angle is 90 degrees. All right. Now, let me take this across to here. Let me take this down all the way. Yes. So let me call this point C for circle, for center A, and then just call it B, and let's call this point D. Now, if this is -2, 1, and this is straight across, the point D would have the same Y value as point B, so that's 1. Because it's 1 to thing there, the X value of D is the same as the X value of C, so the point D is 3, 1. C is 3, 4. Now, to find this angle, and let me call this gamma, and let me call this point A, yeah. So BC, by the way, is just distance formula because B is -2, 1. So BC is just nothing more than, BD squared plus CD squared, which is from B to D is 5. From C to D is 3. So that's just 5 squared plus 3 squared square root. And the answer is root 34. I think that's good, yeah? So if you want to find the angle A, that's just going to be tan inverse of 3 on 5. So A is just tan inverse of 3 on 5. That's easy because it's a right angle triangle. Gamma is just simply going to be, that's 2 because that's a radius. And BC is root 34. So gamma is just sine inverse of 2 on 34. Yeah. Now, so that's that one. Likewise, if you have the point B here still, and the circle is there as well, and you want to find this angle here. Oh, so by the way, if you go back to this here, you want to find the angle here. If you use parallel lines, this angle here is A plus gamma. So the angle, let me call this point E. So the angle EAB is just going to be pi, take away that. So this angle here is plus that is pi. So that's just going to be pi minus A plus gamma. Is angle EAB, by the way. So keep that in mind. Now, let's say that I have my point B here still, my center is here still, and then I have this line here and that line there, the parallel. So, of course, these two angles are the same. Take that all the way across to there, by the way. Take this up, again there. So that point C is still the same, B is still the same. That you don't know. I'm going to take this down now. So that is my point F now. So if you look at this, the angle F, by the way, it was the same as before, which is the same value as the point C, which is 3. That's -2. So F is 3, same X value as C, same as the Y value, which is 1. So now F is the same as D, by the way. So now this angle here is A that we found before. That's gamma because by symmetry that, this tangent, that's the tangent. So if this is gamma that we found before, then this is also gamma. Actually, no. This is, it's gamma still. So you want to find this angle here. Well, that's going to be A. This angle here, rather, is not A, by the way. So I'm talking about this angle here. This angle is not A. This angle is theta, let's say. Yeah. This theta guy is actually this angle here, which was A before. Yeah. So this is D, mind you. So the angle theta is actually A minus gamma. Because if you have a tangent here, let me draw that on that diagram. Then that angle there, which is my theta now, is going to be your A minus the gamma guy, because by symmetry, that's also gamma, this guy here. So that means that theta then is A, you know, which is tan inverse, and gamma, you know, which is sine inverse. So this angle here that you have, and that's theta, so this is theta as well in parallel lines. So this angle here, let me call it, and this is, let me call this H, and let me call this J. So angle J, HB, is actually going to be pi minus theta. And that's basic geometry. Now, you can do this question now. All right, so now you have a circle. Circle is 3, 4. Exactly the same as our other example here. So that's 3, that's 4. Z1 is minus 2, 1. So this is Z1. The definition of arc Z1 minus Z is crucially important in this case. So that's in the form of the arc of Z1 minus Z. So that means it's the angle that the vector from Z to Z1. Now it's important that you know that arc Z1 minus Z, not the same as arc Z minus Z1. They're not the same. So very important you know that. We're looking for arc Z1 minus Z. In other words, the vector starts from Z and Z lies in the circle here. So somewhere on there is my Z, and you want to find the maximum angle and the minimum angle from Z to Z1. So in this case, there's my max, and this is my min. This is my max. This is my min. Why is this my max? This is my max because this size is smaller than this. And because the argument is negative, this is bigger than this. So let me call this guy here, I don't know, capital A. This guy, capital B. The maximum argument of arc minus 2 plus I minus Z is actually minus A. And the minimum arc minus 2 plus I minus Z is actually minus B. And A and B is found by what we just did over here, but I'm going to do very quickly again now. So let me find the max first. So there's my circle. There's my point Z1. There's it, then there. This is point B, by the way, is minus 2 and 1. There's the center. So then you take this straight across to here. Take that straight down. There's point D. There's point C. That's 90 degrees. That's 90 degrees. That was 2. Let me this point A. Yeah. This is root 34. So this gamma here we found before, that was sine inverse of 2 on 34. This angle A here, because that length is 3, remember that one's 5. So A is tan inverse of 3 on 5, as we worked out earlier. And so the maximum argument, and you see this parallel line, so this angle here, if you can see, right, this angle here is the same as that angle there, because alternate angles parallel lines are equal. So that means that this guy is A plus gamma, that angle there. And so your maximum argument is from here to here, which is, so your maximum argument is actually minus pi minus A plus gamma. And A is this and gamma is this. Now, the minimum one, we put it up there so you can see that one too. The minimum one is, let me draw a diagram again. So there's my circle. There's the point B. There's a tangent there. So there's the center. So radius there is 90 degrees. That's 2. This, because that's root 34. That's C. They're going across, going down. This one here, take it across as well. So you want to find, that's 90 degrees. This big angle here, remember, was A. So in other words, that's D, that's B. So I'm saying BCD was actually A before, if you look at it. Yeah. So BCD is this angle here. See, it was A. And by symmetry, this is circuit geometry too, that we found this was gamma, this angle here. So that's also gamma by symmetry. So I'll draw the circuit geometry theory for you. If you have a tangent drawn from outside, then these two angles are equal because of symmetry. So tangent from external point are equal, so these two are equal. That's the radius equal, so these two angles are equal. So you want to find, in terms of the argument, the minimum argument, you want to find this angle here, theta, by parallel lines. That's parallel to this. So this angle is theta. And theta is actually angle A. This whole thing is A minus gamma. That's what theta is. So theta is A minus gamma. And A we found and gamma we found. And the minimum argument in that case is, since that's theta, the minimum argument from here to here, which is minus pi minus theta, but theta is that, so it's going to be minus pi. Oh, I'm going to dance there. Okay, you can't see, sorry. So it's minus pi minus A minus gamma. So basically, you will go minus pi plus A minus gamma. So that's basically A minus pi minus gamma. And that's your minimum argument. And that is why that's the hardest and longest question they can ask you. They can ask you max or min. Oh, by the way, I haven't answered the question. So the range of argument minus 2 plus I minus Z is actually, it lies between the minimum and the maximum. So the minimum is your A minus pi minus gamma, and the maximum was, you found it here, was A plus gamma minus pi. And that's your max and your min. So the range means what values of arc Z can it be? It lies from the minimum to the maximum. That's what range means, from smallest to biggest. And that's what I'm going to, by the way, to recap, the question was here, find the range of arc Z minus 2 plus I minus Z, given that it lies in the circle. And the answer to the question is actually here.